Hello everybody. Today we will be going over logical operations as they apply to computer science and cryptography applications. Let's just hop right into it. Now, it's going to be a relatively simple lecture today because of there's not too much to understand here, but it is important to note that these are very important operations when you get to more mathematical operations in computer science. Now, this list here is pretty comprehensive over the operations you will find in your careers. Now, starting at the top, we have and, or, not, NAND, NOR, exclusive OR, and exclusive NOR. Now, you'll see I have a star next to XOR. That is perhaps the most important one out of this entire list, as it has several applications in mathematical and cryptographic applications, especially in stream ciphers. Well, we'll get there when we get there. So let's just hop right into it. Now, on the left here, you can see a binary operation that I did, applying the AND operation. And to the right here, you see a truth table with the zeros representing false and the ones representing true. Well, the AND operation is a relatively simple one to start us off with. It returns true if both inputs are true, and only if both inputs are true. So that's a very simple one to start off with. You'll see if any of them are false, the entire output is false. The OR operation has a little bit more nuance to it. If any of the inputs are true, then the output is true. And you can see over on the left there, you have significantly more ones than you did in the previous one. The NOT operation is a little bit different than the rest of the operations on this list, as it only has one input. And again, pretty easy to understand what this operation is doing. It's simply reversing the value of the input and providing an output. So if the input is true, the output is false. If the input is false, the output is true. Not too terribly useful unless you are a programmer, and even then, it's not a very big operation. The NAND operation, or not and, takes a little bit more brain power to understand what's going on. Now, it only returns true if it would return false in the AND operation. So if both inputs are false, or if only one input is true, it'll return true, but not if both inputs are true. It's a little confusing at first glance. The NOR operation is, well, not or. Now, if any of the inputs are true, then the output is false. Likewise, if both of the inputs are false, the output is true. The XOR operation is really what we need to talk about here today. It's represented by that little plus in a circle, and you will see this a lot in cryptographic applications and mathematical write-ups of such applications. The truth table here is not as useful as the binary mathematics on the left. This operation is very, very, very important to us because it can be done incredibly quickly, as it's only a 2-bit operation, and it can conceal the data very well because, well, if you have two inputs, your key and the thing you're trying to encrypt, you won't really know which one is a 1 or a 0. So if the output is 1, it'll produce some gobbledygook. And if you do this over a period of 14 rounds, over a matrix of inputs, then you will have a pretty secure output, and no one will be able to break it quickly anyway. Now, make sure that you understand the XOR operation. It's exclusive OR, so it will only return true if one input is true and the other is false. Not if both are false, and not if both are true. The binary operation on the left here shows us the output of a simple cryptographic function, whether it be a hash or encrypting it itself. Make sure that you know this. Moving on, we have exclusive not OR. It's basically the opposite outputs of exclusive OR. This one's not so easy to call important as, well, it's kind of hard to reverse due to the fact that both inputs are, well, it's not hard to reverse. It's insecure. If people know you're using XNOR, they'll know your inputs are both the same.